Recording is rolling. It is Thursday, April 3rd. So we're going to do Kahoot today. A lot of you guys are already on that. Pins on the board. Okay, so yesterday, a bunch of you guys turned in this page. Remember, there were 4 Kirchhoff tables and some models on this side, which we did together in class. And on the opposite side are a bunch of circuits. We did about half these together in class. If you turned it in yesterday, I already have it scored and in the gradebook for you guys. If you haven't turned it in yet, then turn it in soon. No, also grade up here. You guys know tomorrow what's going on in this class tomorrow. Quiz tomorrow. And all these blue banner posters hanging up from my ceiling, I'm just going to leave exactly where they are. Let's do a little bit of a review, which, by the way, the Kahoot today, you're going to see some questions that I bet are going to show up on your quiz tomorrow. Right? So start with Ohm's law. You guys know, what does Ohm's law say? So the current that flows through a circuit is equal to voltage over resistance. Or you could rearrange this a bunch of different ways. So you could go voltage is current times resistance is another way to do that. Okay. So there you go. Voltage, current, resistance have that relationship. How about Joule's law? What does that say? Could you guys go power is current times voltage? That's one way to do it. And here's some other iterations of that. Use sub and Ohm's law. You guys could do Joule's law. Okay. Got that. How about can you guys calculate resistors in series? If you have a bunch of resistors in series, what's the total resistance? Or how would you find that? Very simply, add them all up. Yeah. So if you have a bunch of resistors measured in ohms, just add them up. But what if the resistors are in parallel? Then how do you find the total resistance? You have to do what? Or what? You guys got some options now. Guys, if there's only 2 resistors in parallel, you can do what divided by what? Aha, product over sum. Exactly. Yeah, product over sum. Okay. What if you have 10 resistors in parallel? Could you use this reciprocal method? So like 1 over, or add the reciprocals and then take that reciprocal? Okay. And hang on a minute. Isn't this exactly the same math as a bunch of people working together in a team to complete a project, and how much time would it take? So how about painting a fence? So it takes Alan some time to paint a fence, and Bob some time, and then Chad some time, and so on. Derek, Eric, and Ferret. Can you do 1 over plus 1 over? Right? So you can do that. It's the same outcome, isn't it? So how about this? If you have more and more and more resistors in parallel, what happens to the overall resistance? Guess what? More or less. It's less. It's less. Right? Exactly the same as if you have more and more friends painting the fence, it takes less time to paint the fence, doesn't it? Right? It's the same math. Same math. Okay. And finally, yesterday you guys did a lab to find out what's the resistivity of Play-Doh. Resistivity is a material property. Copper has some resistivity. Aluminum has some resistivity. Play-Doh has some resistivity. Yesterday at the end of the lab, you guys had a number. How many ohm meters of resistivity? Right? So tomorrow, you guys are going to get a question on the quiz that looks a lot like the lab you guys did yesterday. So let's look at this formula. This formula says the resistance from end to end of a wire is directly proportional to its length. So if it's 1 kilometer long versus 2 kilometers long, right, twice the length is twice the resistance. The resistance is inversely proportional to the cross-sectional area. So if you have a thin wire versus a thick wire. Today, in the Kahoot, you're going to see some questions talk about a light bulb with a thin filament versus a thick filament, right, inside the bulb. That's talking about this cross-sectional area. The thicker the wire, the less the resistance. And then you have this resistivity factor. Okay. So if the lab yesterday, you guys measured the length of your dough cylinder. I guess you guys made a dough cylinder that looked like this. So that goes in place of the L. You guys measure the diameter, and then pi over 4 times diameter squared is the cross-sectional area. You guys see that? Okay. And for this resistance, you guys used Ohm's law. You guys use the ammeter to get the current and the voltmeter to get the voltage, and you guys can calculate the resistance, and that goes right here. Right? And that's this whole process right here. And it all led up to finding the resistivity. So when you guys see that question tomorrow, you guys will be able to find the resistivity through that method, exactly like you guys did yesterday. Okay. So that's all showing up on the quiz. All right. Right before we do the Kahoot, one more thing. I got an email from admin today. So if you are a senior, who's a senior in here? Who's a senior? Senior. Maybe my other classes, so this is for the video anyway. Is on Tuesday, April 8th, so it's coming up in a few days. During period 3, they're going to call the seniors down to the media center to talk about Bright Features information. Now, way I was reading the email, I think they're going to call you guys in two groups. So last name A through M and then last name N through Z. And this might go a little bit into fourth period, they're thinking. So that's Tuesday coming up for seniors. And third period, they're going to call you to the media center. All right, I think it's Kahoot time. Let's wait for Kahoot. Oh, yeah, you guys ready to go? Here you go. Kahoot. In order to form an electric circuit, you need to have a complete path for the current, a power source, a light bulb, or for some form of resistance, all the above. Yeah, all the above. You want all those. Okay. If you don't have a complete path that would be open, no current's going to flow. You have to have some providing the energy, right? Like maybe a battery provides some kind of voltage. Guys, if you don't have a resistor, then that's a what kind of circuit? If there's no resistance, it's called a what circuit? Short circuit, which is not ideal unless you're trying to start a campfire. But other than that, you really want some kind of resistor in your circuit. Okay? All the above. Very good. All right, got points on the board. In order for current to flow in a circuit, you must have a complete path of the current or a switch that's open. Which one of those is true? Yeah, complete path. Complete path. So, stick through my posters here. Here's my flashlight schematic. Okay. So, if I have the switch that's open, guys, if it's an open switch, is any current going to flow? No, the light's turned off. But if I close the switch, it's like hitting the off switch. Right, now there's a complete path for the current flow. You have to have a path from the positive to the negative terminal of the battery. Okay. And if you don't have all that, then no current flow. Has to be a closed circuit. Got Luciana, Jonathan, good boy. Got Moose the first of his name, Alexander, and Peyton. Electrical resistance is measured in resistance. Ohms. Aha. And that's Greek letter omega, isn't it? Greek letter omega for ohms to measure resistance. Guys, what does joules measure? Some amount of energy. You guys think in a battery there's some finite amount of chemical energy stored there? Yeah. Okay. Volts measures, could you guys say voltage or potential difference? Okay. Potential difference or voltage measured in volts. Guys, what does amperes measure? Current, electric current. Aha. Like coulombs per second. That's an amp. Okay. Olivia, Alexander, Elise, Moose the first, Peyton. Closed circuit is a circuit in which charge can flow. This is the same thing as the schematic here. If you hit the on switch, you're closing the circuit. And when it's a closed circuit, the current can flow. If you break it open, the light turns off. Close it, the light turns on. What's wrong with my computer? There you go. Luciana, Alexander, Peyton, Elise, Moose the first. When two bulbs are connected in series, is it the same current always through each bulb? Or is the current proportional to the resistance? For series setup, two bulbs in series. Yeah, it's always the same current through each bulb. Even if the resistors are different, it's always the same current. Okay. Let's look at Kirchhoff rules. Okay. Well, you're going to trend because remember, Kirchhoff really only had two rules. He has this loop rule. If you identify any loop, the voltage is 0. And this junction rule, which is if the current splits, it all has to add up and equate. Right. But really, all these rules sort of apply. A lot of these. So the question you guys just got is this question right here. For a series setup, we have one after another. The current is always the same. Now, one of my analogies for current has been traffic flow. Guys, if a bunch of cars leave this parking garage, drive around town back to the garage, and I got like 3 stoplights here and 5 stoplights here, do all the same number of cars go through those stoplights and also those stoplights? Yeah, they sure do. So the current has to be the same everywhere. Another analogy I've been using for current is like flow rate of water, right? Is it the same gallons per minute down every one of those waterfalls that's in series? Yeah, it's the same gallons per minute everywhere. And then back to electricity, it's the same current in amps everywhere. Right. You know what? While I got this page up, let's look at the rest of the rules. So the voltage just drops proportional to each resistor. That's kind of like saying on my waterfall model, whoops, skipped over the thing. Here it is. Okay. The heights of these waterfalls could be different from each other, right? But they have to, of course, add up to the original battery. That's the loop rule again. Okay? I bet you guys are going to see some Kahoot questions on parallel also. So let's look at parallel. Guys, what's always the same for resistors in parallel? The current or the voltage? The voltage. Aha. You see, for parallel, right? Like if this is a 9-volt battery, I got 9 volts right there. Isn't 9 volts across this one and 9 volts is also across this one? Even if the resistors are different, it's always the same voltage drop. Okay. Now the current's gonna probably be different. The current's gonna split. Maybe you guys think, you guys speaking of current, suppose I have a 1 ohm resistor here and a 9 ohm resistor here. Does more current go through 1 ohm or through 9 ohms? Through the 1 ohm. That's like saying if there's 1 stoplight here and 9 stoplights along this street, most of the traffic's only going to go through the 1 stoplight. And I have a few cars trickle through the like 10 stoplight or 9 stoplight. Okay, but path of least resistance. Most of your current goes through the path of least resistance, and that's what this very last formula says right here. Okay, the current through branch A is proportional to the other resistor. Okay. And what does that look like on the model for parallel? Here we go. Okay. So notice that the height of the cliff, the height of the battery, same as the height of every single waterfall. Okay. That's resistors in parallel, always have the same voltage. Okay. Now the current could be different. Is it okay if you have a wide waterfall here and a skinny waterfall here? Yeah, and that could represent the current in amps. Right. All right, so there you go. So a lot going on right there. That poster's hanging right here in my room. If you're in class, you can see it. That might be helpful tomorrow on the quiz. All right, so you guys good with that? All right. The symbol used to represent resistance in a schematic diagram. Zigzag. There you go. So you see lots of zigzags on these schematic diagrams. Those are resistors. Right. Got Luciana, Alexander, Peyton, Elise, Bruce the First. When resistors are put in series, the overall resistance increases. Yeah, it's larger. That's this right here. Here. Guys, if you weren't sure about larger or smaller, could you just throw some numbers at it? Like, guys, what is this? Is 10 ohms, 10 ohms, and 10 ohms. What's the total resistance? 30, because you just add them up. Right? Right. As long as they're in series. Okay, so for series, you just add them up. The more the resistors, the more the resistance. When resistors are put into parallel, the overall resistance is in parallels. There you go, smaller. Yeah. Right. There's a few ways to make think about this. Next there. Right. So again, you could throw some numbers at it. Or how about this analogous story? Could this be 3 guys painting a fence? What if it takes this guy 30 hours, takes Alan 30 hours, takes Bob 30 hours, takes Chad 30 hours, but they make a 3-man team? Now how long does it take as a team? 30, 30, and 30. You can knock out the job in 10. Guys, it's got to be 10 hours, right? Because if they all work at the same rate and there's 3 of them, can they knock out the job in a third of the time of an individual? Right? Let's run the numbers on that. Let's try that. What's 1 over 30 plus 1 over 30 plus 1 over 30, and then take the reciprocal of that. Yeah, it is 10. Oh, look at those. Right there. Now you could do product over sum, but guys, what's the catch with product over sum? You can only do how many at a time? 2 at a time. So I could go 30 times 30 over 30 plus 30, which is 15. And then I need to bring in the third guy, so it'll be 15 times 30 over 15 plus 30. And I can still get to 10 that way, but I have to do it in multiple steps. Okay. How about this? Guys, resistors in parallel. Is the total resistance going to be less than that of the smallest resistor? Here's another way of saying that. If it takes you 1 hour to paint a fence, it takes your friend 10 hours. Then if you paint the fence together, is it still going to be faster than you painting alone? Yeah, maybe not much faster, but it will be a little faster. See that question later. You guess that later. Olivia, Alexander, Peyton, Elise, who's the first? On fire. As more lamps are put into series, the overall current does what? Decreases. The overall current decreases. So here, you can think of this in 2 steps. So step 1 is, oh, whoops, let's get back to series. All right, so back to series. Okay. As you put more and more in series, does the overall resistance increase? Yeah, so the overall resistance is increasing. And then over here, because if the resistance is increasing, what's happening to the current? Decreasing. You see, I and R are inverse. Okay, so one goes up, the other goes down. Okay. And I can kind of show that too with, I got a 9 volt right here. I got some bulbs in series. You guys see 3 bulbs in series? Now if I just do 1 bulb, ooh, look how bright. That's really bright bulb. What about 2 in series? Huh, not as bright as before. What about 3 in series? Oh, now, okay, now they're getting kind of dim. It's still on, but they're getting kind of dim now. Okay? So maybe that could also be an indication that there's less and less current flow. It's well, bigger than that, but. No, all right. All right, guys, good? Are we good? All right, if you guys got any questions, let me know. Yeah, Alexander, Olivia, Elise, who's the first? Peyton. As more lamps are put into parallel, the overall current yep, increase. So this is just the reverse, isn't it? Because the more resistors you put into parallel, see if you guys follow this. What happens to the overall resistance? It's less and less and less. Like the more people painting a fence, the less time overall it's going to take. Okay? And then jump over here and say, if the resistance is getting smaller, the current is getting bigger. Yeah, you got it. Right. And finally, let's do the physical model. So 9 volts, 1 ohm resistance. Right. You guys see a bunch of, okay, so that's pretty bright for a single bulb. All right. But what if I have 3 in parallel? Ooh. Well, if a single bulb was like 1 ohm, I bet this would overall be like a third of an ohm. Right. But let's see what happens in terms of current. Right. Well, guys, is every single one of these bulbs about to have the full 9 volts going across it? Yeah, what's that going to look like? Pow! Now, every single one of these is really bright. Right? Okay. So now compared to 1 bulb, right? Now this battery is supplying 3 times the current it was to 1 bulb because it's 9 volts across this one, 9 across this one, 9 across this one. Right? So every one of these is getting some current. Okay. Right, there you go. Parallel. Olivia, Alexander, Elise, Peyton, who's the first? Compared to the resistance of 2 resistors in series, the same 2 resistors in parallel is? Yeah, not as much. If you want to, could you throw some numbers at that? Let's do 10 ohms. Guys, what is 10 and 10 in series? 20. 10 and 10 is 20 in series. What is 10 and 10 in parallel? Can anybody solve that? If it takes you 10 hours to paint a fence, your friend 10 hours, you work together. How long does it take the job? 5 hours, right? Let's do product over sum. Guys, what is 10 times 10? 100? And then 10 plus 10 is 20. What is 100 divided by 20? That's also 5, isn't it? Aha. Right. So in series, 10 and 10 is 20. In parallel, 10 and 10 is 5. Ooh. Right? You guys got that? All right. When one bulb in a series circuit containing several bulbs burns out, yeah, none of the other bulbs will light up. And I can show that to you guys. So here's 3 bulbs in series. What if one of these bulbs burns out? Doesn't that open the circuit? And now there's not even a path for the electricity to follow, is there? So the current can't get back. So now everything else turns off. It just opens the circuit. Okay. I remember back when I was a kid, so this is way back in the 90s. I don't know how they manufacture it anymore. We used to have, okay, so strings of Christmas lights. And they were 2 different designs. And one design, yeah, if one bulb went out, the whole chain went out. But there was a different way to manufacture these. I think it's how they put these together today, which is more like this. If you put them in parallel, I think that might be the question coming up. Now, what if one bulb burns out? What happens to the other bulbs? They stay lit. Exactly the same as before. Because if I have 9 volts down here, then they each still have the same 9 volts going across them. Yeah, a 9 volt right here, right? Okay. So if you have a string of Christmas lights and one burns out and the others stay on, then you know they were connected in parallel the whole time. Yeah. Yeah. Luciana, Alexander, Elise, Peyton, Bruce the First. There you go. One light bulb in a parallel circuit burns out. The other bulbs. Same as before. Same as before. Okay? Because it's the same voltage across each individual bulb. And each bulb, of course, the same resistance. Yeah. So same current through each individual bulb. Right? Now there'd be less overall current supplied by the source, but the same current through each individual bulb. Yeah. Just the same brightness before. Luciana, Alexander, Elise, Peyton, who's the first? And a simple parallel circuit, is the current through each branch always the same, or the voltage drop across each branch always the same in a parallel circuit? Look for voltage is always the same in parallel. So that's this page right here, right here. Okay, so we're talking about parallel. This is parallel right here. Okay. Because if this was my battery, I got 9 volts. Boink, right there, 9 volts. Would there be 9 volts across this and also 9 volts across this? And that's exactly what this line. This was the answer to that question. It's right here. This is the answer. Now the current, however many amps are supplied, that's going to split, isn't it? Okay. Now the current could be the same if the resistors are the same as each other, but they don't have to be, and that's not going to universally be true. If there are different resistances, you'll get different currents through each branch. Okay. You guys, where does most of the current go? Does most of the current go through the smaller resistor or the larger resistor? More current goes through the path of least resistance. More current goes through the smaller resistor. That's what this fraction says down here. Here, let's put some numbers to this, because I did this one verbally, but let's put some numbers. Let's say I have, let's throw 12 volts on here. And what should I do for resistors? Let's do 2 ohms versus 1 ohm. Well, okay, that's what we got. We'll go with it. Okay, you guys see that? Let's solve this whole thing. You guys ready to solve the whole thing? Okay. Guys, does each of these have a full 12 volts going across it? Okay. And let's do Ohm's law. Ohm's law. Okay, go I equals V over R. Okay. So what is 12 volts divided by 1 ohm? So I have 12 over 1. Is that 12 amps? And what's 12 divided by 2? That'd be 6 amps. Okay. So how much total current is there leaving the battery? 18 amps. You guys see it has to be 18 amps? 18 cars. 6 cars split that way, 12 cars split that way. Okay. You can see how more current goes through the path of least resistance? Okay. Or there's another way we could have solved this too. We could have said the total resistance is product over sum of 1 and 2. 1 times 2 over 1 plus 2 ohms. That'd be what, 2/3 of an ohm. And then done Ohm's law. Guys, what is 12 divided by 2/3? That's 12 times 3 halves, which is 18. That's a different way you could have got this too. It's a different way of looking at it. Okay. Okay. In fact, if you'd done that first, if you started by knowing that there's 18 amps leaving this battery, and you said, well, how does that split? Okay, now we're getting to this fraction. And this is really what I'm doing this on paper for. I want you guys to see this. Okay. So, let's say the current through branch A, let's say it's top branch, is proportional to the opposite resistor. So I'll say the current through A is resistor B, which is this 2 ohms right here. Plus resistor A, plus resistor B. So I'll go 2 ohms out of 1 plus 2 is 3 ohms. So 2/3 of the total current, which is 18 amps. Okay, guys, what's 2/3 of 18? That'd be 12 amps. Which is exactly what we got from a micro approach applying Ohm's law. We got 12 amps a different way before. Okay. Now I just navigated this form and I still got 12 amps. Okay, let's do one more of those. What's the current through branch B, which is this branch right here? Now you guys know the answer is going to be 6 amps, but I want to show it a different way. Okay, so if I know there's 2 ohms here and 1 ohm here, I'm going to do the opposite branch, which is 1 ohm over 1 plus 2 of the full 18 amps. Is what's 1/3 of 18? 6 amps, okay, which is of course exactly what we got before with a different method. Okay, so you guys see how that works? All right, a little detour right there. Okay, so more current goes through the branch of least resistance in a parallel circuit, but voltage is the same across. Luciana, Alexander, who's the first? Elise, Peyton. In a simple parallel circuit, so we're sticking parallel. What else? Is the current through each resistor inversely proportional to the resistance. The current is divided into each branch. The voltage across each branch is the same. All of the above. What's true for parallel? Yeah, those are all true statements. For parallel, those are all true statements. So we were just looking at. Same thing. All true. Luciana, Alexander, who's the first? Elise, Peyton. Fuses and circuit breakers are used to yeah, there you go. All the above. So the symbol on the diagram, we haven't talked about this very much, but that's this one right here. It says, guys, have you ever plugged in something to an outlet and it kicks the power off? You maybe have to like reset it or go find your circuit breaker and hit a switch. So there's something that's breaking the current, and that's for safety reasons. Because if too much current's flowing all of a sudden, then that might be a dangerous situation. You might be starting fires. What if you have some kid that's running around like shoving these paper clips in the outlets? Right now, the current's going through the kid, and that's not good. So there's too much current flowing. There's going to be some process like maybe this fuse could burn out, and if this fuse burns out, doesn't that open the circuit? No current flows. Right, so something like that. Okay. But that only works if the fuse is connected how to the circuit, in series or parallel. The fuse has to be in series. Because here, let's say here I'm showing it in series, but let's look at a parallel just to show how it would not work. So here's parallel. Okay. What if I put the fuse right here and the fuse burns out? Doesn't current still flow through the other resistors? Right. Yeah. So you definitely want your fuse in series. All right. Start that. All right. Green. I got some winners. Oh, a short circuit. what are we talking about when someone says a short circuit? Are they talking about very short wires in the circuit? The current lasts for a short time? Or is the positive lead connected directly to the negative lead? What does a short circuit mean? Yeah, after this, yeah. Yeah, positive connected directly to negative. You could also say if there's zero or negligible resistance in the circuit. Now, ideally, you do want some resistance because short circuits, you typically don't want those. You want there to be some resistance. All right, got Luis the First, Luciana, Alexander, Elise, Peyton. Two lamps, one with a thick filament, one with a thin filament, connected in series. The current is greater in the lamp with the thin filament. Or sorry, whoops, sorry. Sorry, series. Same. But sorry, I was thinking parallel. Oops. So series is always going to be the same. Okay. So there's a few of these questions that talk about thick versus thin filament. Okay. So guys, when they say thick versus thin filament, they're talking about this cross-sectional area, which tells you something about the resistance. Guys, what has more resistance, a thick or a thin filament? Yeah, I think if it's thin, that'd be a small cross-sectional area would be a larger resistance. Okay. Okay. Now, if you look at resistance, and then what's everything going on with resistance? Now they said series, the current is always the same in series, even if they're different resistances. Doesn't matter. It's always the same current. Right. Now, yeah, I just really quick. I was thinking it said parallel. When you see that question, you're gonna see that question too. Because what do you know about parallel? Is the voltage always the same in parallel? Yeah, but the current's going to split. The current's not necessarily the same. The current's probably different. Yeah. Okay. All right. So there you go. So in series, the current's the same everywhere. In parallel, the voltage is the same everywhere. All right. Boom. Do good. Two lamps, thick filament, thin filament, connected in series, same as before. The voltage is greater across the lamp with the yeah, thin filament, which would be the greater resistance. So the greater the resistance, the greater the voltage drop in series. Okay. So back to that with the equation here. So that's this one right here. This one right here. It says the voltage drop, say across resistor A, is proportional to resistor A. So you guys, suppose you have 7 ohms and 3 ohms. You guys see that? 7 ohms and 3 ohms is 70% of the voltage drop across A, and the other 30% is across B. That's exactly what this proportion says right here. Okay. And then if you want a waterfall model, we're looking at this right here. So resistors in series, the voltage, there's going to be a series of voltage drops. Now they have to add up to the original battery voltage, but say like the height of each waterfall, you could say is directly proportional to the resistance. So the voltage drop is directly proportional to the resistance. For series, that's true for series. Okay. I think there might be some parallel questions coming up here. See if that's true. Two lamps, thick filament, thin filament, connected in parallel. The voltage is greater across the lamp with the, we're talking about parallel. Voltage in parallel. What do you guys know about voltage in parallel? Is always the same. Voltage in parallel is always the same. Okay. That's this rule right here. Right here. Okay. So again, if you have 3 ohms here and 7 ohms here, they're different resistances. But if you have a 9-volt battery, isn't it 9 volts across this one and also 9 volts across this one? Yeah, it's the same voltage. Same voltage. Okay. Okay. Now they'll have different currents going through them. That's okay. But same voltage. And if I find my waterfall model. for parallel. Here's waterfall for parallel. Right. What that means on the model is that the height of the waterfall is the same as each other. So all the same heights. Right? Now you might have a thin waterfall next to a thick waterfall that might represent a small current next to a large current. Okay, that's okay. Okay. But they all have the same height change. That's all the same voltage drop right there. Good shot. Oh, whoops. Next question. Two lamps, thick filament, thin filament, connected in parallel. The current is larger in the lamp. Where does more current go? Does more current go through the thick filament? Or does more current go through the thin filament? If you hit a road junction in your car, you look one way, you see a one-way street. You look the other way, you see a 10-lane superhighway. Are you probably going to take the 10-lane superhighway? Yeah, because that would be the path of least resistance, right? Okay. So how about, what does the math say about that? That's this one right here. Okay. So the current splits, but more current goes through the path of least resistance. And less current goes through the path of more resistance. Okay? And least resistance is the larger cross-sectional area, and that brings you back to this one too. So this also has a tie-in to yesterday's lab, right? The more cross-sectional area, the thicker the wire, the less resistance, right? Which is where more current wants to flow, through the path of least resistance. Luciana, Alexander, Elise, Peyton, who's the first? Is back. So you got a bulb connected to a car battery. When you put an identical bulb in parallel, what happens to the battery's output energy? Don't worry about the numbers. Just, you have a parallel setup. Every time you put on another bulb in parallel, what does the battery do? Yes, so more current, has to supply more current. Okay. Here, I'll show you guys that with this model right here, I'll show you guys real life version. Okay. So here's a 9-volt battery. If I put one resistor across it, here, let's do some numbers. Guys, if this is 9 volts and this is 1 ohm, how much current is this right here? What is 9 volts on 1 ohm? 9 amps. Could this be 9 amps? Okay, so let's call it 9 amps. Okay. But what let's not do 2, let's do 3. Is what if I have 3 in parallel? You guys see how the leads are tied together? Right, so 3 in parallel. Right. So across each individual bulb, is that 9 amps across this one, and 9 amps across this one, and 9 amps across this one, for a total of 27 amps leaving the battery? Is that 27 amps leaving the battery? Yeah, yeah. Okay. So okay, so every time I put on another resistor in parallel, the battery now has to supply voltage to that one, and the next one, and the next one, okay? Which means it's supplying more current, and the battery is being drained faster. Okay? So same voltage across more in parallel is more current and more power from the battery. We got Zach, Alexander, Peyton, who's the first? Elise. Top spot. The total resistance of 9 ohms and 10 ohms in series. What is 9 and 10 in series? Yeah, 19 ohms. So you just add them up, right? Add them up. 9 plus 10 is 19. Is that okay? 9 plus 10 is 19. Oh, yeah. The total resistance of 10 ohms and 10 ohms in parallel. What is 10 and 10 in parallel? 10 and 10 in parallel. If it takes you 10 hours to paint a fence, it takes your friend 10 hours to paint a fence. You team up together. How many hours does it take? If you team up? Yeah. Yeah. Half the time to paint the fence, in terms of ohms, it'd be 5 ohms. Right? Or, guys, could you do product over sum? Product over sum? Well, let's do that. Because what is 10 times 10? 100. What is 10 plus 10? 20. What is 100 divided by 20? Ah, here's 5 ohms right there. It's another way to get it. Right. So do you guys see the rule for parallel? If you have two resistors that are identical to each other in parallel, the overall resistance is always going to be half of either one. You guys see that? That's a good thing to know. Got Luciana, Zach, Peyton, who's the first? Elise. Current through 2 identical light bulbs in series is 1 amp. The total voltage is 140 volts. What's the resistance of a single bulb? Here, I'll walk through this with you guys. Can you guys imagine did they say series setup? Oh, there it is, series. Right. So one after another in series. Right. Let's do Ohm's law. If I have 140 volts and 1 amp, then what's the total resistance? Is it 140 ohms total resistance? Right? No, that's for the whole circuit though. Do you guys see 140 over 140 would bring you to 1 amp? Right. Right. Then if you have 2 bulbs in series, don't you add them together to get the resistance? Which is 140, and if they're identical, what plus itself is equal to 140? 70? Is that it? Right. So you guys see it has to be 70? So if you put 70 and 70 in series, that creates 140 ohms. Then 140 volts acting on 140 ohms gives you 1 amp. Okay, let's see. I gotta draw that out. Let me draw that one out. Okay. So what we just did is like this. Here, I'll solve this one backwards. I know this is 140 volts right here. I'll start from the answer. So this is 70 ohms and 70 ohms. Is it? Guys, that's a total of what? How many ohms? 140 ohms. So the resistance total is 70 and 70 makes 140 ohms. Okay. Now let's go over to Ohm's law. Current is voltage on resistance. So I got 140 volts battery, which is from right here, acting on 140 ohms resistance, which is from right here. Doesn't that give me 1 amp? And since I solved this whole thing backwards, and a premise, they gave you 1 amp of current. Okay. All right. Boring. Okay, you guys good with that? In order to make a flashlight bulb light up, all you need to do is run a wire from the positive terminal of the battery to the center of the bulb's base. True or false? False. I have a diagram just for that scenario. That's this one right here, right. So if you run a wire from the positive terminal to the bulb's base, guys, that's only half the story. That's not even a complete circuit. The bulb's not going to turn on. To make the bulb turn on, you have to force the current to flow through this filament, and then you need a lead connected to the negative lead of the battery, end of the battery, right? So you have a complete circuit, right, from the positive to the negative into the battery, and the current has to be forced to flow through the filament of the light bulb. Okay. So we need a complete closed circuit. Zach, Luciana, Peyton, Elise, who's the first? 2 bulbs connected in series. They all carry the same current regardless of their resistances. True or false? True. Yeah, you guys are on. So that's this one right here. This one right here. Series, it's always the same current. Even if it's 1 ohm and 99 ohms of resistance, it's always the same current. Yep. Same current. In a series circuit, the total voltage drop across a series of resistors is the sum of the voltage drops across each individual resistor. Be true. Yeah, true. Nice. Mr. Guys got that. We back that up with my posters over here. Okay, so here's my waterfall model. Because another way of saying that is if I add up the heights of all these waterfalls, does that add up to the height of the cliff? Yeah, you guys see the same thing? Okay. which goes by another name. It's called the loop roll. Is that Kirchhoff's loop roll? It's the same thing? Yeah. So there's a few perspectives. Same thing. Luciano, Zach, Peyton, who's the first? Elise. Woo! Win by 7 points. In a parallel circuit, current in each branch is the same. True or false? False. Aha. Ah. That's this right here. So parallel, here's parallel. Right? Yeah, the current's going to split. Now the current could only be the same if the resistors are also the same as each other, but that's not universally true. What is the same in parallel? Parallel, what has to be the same? The voltage drop. Yeah. Alexander, Peyton, Zach, Elise, Moose the first. A schematic diagram is a simplified, blocked out picture of a circuit in which the parts of the circuit are represented by symbols. Schematic diagram. Yeah. When resistors are in parallel, their overall resistance is less than that of the smallest resistor. It's true. Ooh, 2 winners for true. Okay. Here, give you guys a couple of perspectives on why this has to be true. Here's resistors in parallel. Here's the total equivalent resistance. Okay. Let's do painting a fence method. Isn't that the same math, painting a fence? Guys, if it takes you an hour to paint a fence, and it takes one of your friends like 10 hours to paint the fence, and you work together, isn't it true you'll knock out the job faster than you could alone? Even if your friend is really, really slow at painting, you can always do faster as a team than you could by yourself. Isn't that true? Right? So here's another perspective. Let's throw any numbers at this. Guys, what if this is 1 ohm? Well, let's just do 2 resistors. What if I got 1 ohm and 10 ohms? Is that okay? Let's do 1 ohm and 10 ohms. Does this have to come out to less than an ohm? Is that really true? Well, let's find out. What's 1 times 10 over 1 plus 10? Yeah, it is. It is a little bit less than an ohm, isn't it? Kind of like if it took you an hour and your friend 10 hours, you can knock out the job in 0.9 hours. Okay, that's it. There you go. Resistors in parallel. Every time you add a resistor in parallel, the overall resistance always decreases. Yeah. Alexander, Peyton, Zach, who's the first? Elise, put him in the top spot. In order to prevent overloading in a circuit, fuses are inserted into the circuit. Yeah, true. And for the win. Oh, here we go. We got Alexander, Peyton, Zach, who's the first? Elise. And for the win. A fuser circuit breaker is usually inserted in parallels. True or false? False. False. Because if you put a fuse right here and it burned out, well, it wouldn't do anything because the current would still flow somewhere else. But where's my series set? Or actually, here we go. Here's a fuse that's in series with the rest of the circuit. If that fuse burns out, that actually will stop the flow of the current, which is exactly what you want. Yes. All right, let's go to the podium. Who won Kahoot? With the bronze, Zach. The silver, who's the first? And the gold, Elise. All right, nice job, guys. And that is a close on class.